So 12th class. So you are from which institution, ma?
Silver Oak, sir, CBSE.
CBSE. And Anjan, what about you?
Sir, I'm 12th, intermediate second year.
Okay, intermediate second year. Okay, so you're studying in which college?
Sri Chaitanya, sir.
Sri
Madinabad.
Chaitanya. Okay, okay. Which branch, ma?
IIT Academy, Madinabad, sir.
Okay, 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 okay. And Aditi. Hi, Aditi. Aditi, are you able to hear?
Yeah, sir.
Yeah, ma. So, and which school? So you're from which school, ma? I mean, school or college?
Kshetra.
Ma?
Kshetra.
Okay, okay. So you're also plus two, all are plus two only, yeah?
No, I'm from +1.
So you are from plus one. Okay, so remaining all are plus two. Okay, so all are preparing for JEE only, na? Is any medical students are there?
No, sir.
So all are JEE only. Everyone you are preparing for JEE only. So then good. Okay. And so, sir, I think it's already got the date also, examination date. So when you're having JEE exam, do you have any idea?
Yeah, sir.
Ending of January.
Yeah, so January one session is there, and I think so May one session is there, na?
April ending, sir.
April ending. So this time also they had given two sessions only.
Yes.
Okay, so before that they used to give us four sessions. So due to from last 2 years they are giving us only two sessions. Okay. So anyway, what were your portion status and return? So which portions are going on there? I don't know exactly. Okay. If you give exact information is based on that, I'll start the chapter. So 12 portions are completed for everyone. Anja.
Organic, can you start, sir? Organic.
So
From
like
hydrocarbons.
organic chemistry, and I guess we completed aromatic compounds,
Okay.
aromatic, anti-aromatic compounds.
Okay.
From nomenclature till there. Yeah.
Okay. From nomenclature again I had to start. Okay. So for everyone,
Yes, sir,
GOC
yes, sir.
started.
Completed nomenclature to anti-aromatic compounds. Till that we completed everything.
Okay. 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 Anjan, you are telling something, Anjan.
Sir, it's trying to start with hydrocarbons, sir.
So better to start with the hydrocarbons. Okay.
Yes, sir.
So okay. So because of somebody basics is very, very important, of course. Huh?
Sir,
Yeah. Still
why
anyone.
why don't you start with GOC, sir?
So okay, anyway, one second, I'll revise, no problem. Then
Yes.
so Veda and others. Samhita, what about you? Dheeraj also is there. Hi Dheeraj.
Hi, sir. Hi.
Hi, how are you? So Dheeraj, you are from which school?
Sir, I am a dropper, sir.
Dropper. Okay, 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 okay. Then so next, no problem. Samhita and Samhita, what about you? Can I start with GOC? I think so already you are feeling that some part is finished. Anyway, once again I'll revise that.
Yes.
Okay, so while discussing, just it's a keep on discussion tomorrow onwards. So we'll start the serious class. So because I don't know the exact information, so today just we will discuss about the GOC. As per you, everyone you're asking the GOC, general organic chemistry. Okay, and then so just wait for some time. Okay, I'll try to finish as early as possible. Then we'll go for the hydrocarbons. Okay.
Yeah, sir. Okay, sir.
Okay, so because of everyone they're asking the GOC, na, then I'll start with the GOC. Okay. Right. Then, so now I'm going to start the class. Share the screen. Right, my GOC, General Organic Chemistry. General Organic Chemistry. Okay. So everyone you are telling that so GOC is completed up to classification of the elements. Is that clear? Okay. So first of all, what is the organic chemistry now? So make it fast. This I'm reviving. I'm recalling all the concepts which you studied just.
Study of hydrocarbons and their derivatives.
Okay, study of the hydrocarbons and their derivatives is called as organic chemistry. Next, and is any other definition? Whether there is Samhita.
Sir, elements like carbon, hydrogen, oxygen, nitrogen, sulfur, phosphorus,
Okay,
all their compounds, like the study of these compounds is called organic chemistry.
organic chemistry. Aditi, good ma. Next, is any other one? Actually simple. I will tell here. So as per my knowledge here, so organic is signifies the life. Organic is here signifies life. Okay. So what is the organic chemistry? Means organic chemistry is the branch of chemistry, so which deals with the study of the compounds which are obtaining from the living organisms. Okay. So what is the organic chemistry means here? Organic chemistry is the branch of chemistry. You see, in chemistry means we have different branches are there. Physical branch, physical chemistry is there, inorganic chemistry is there, and organic chemistry, analytical chemistry, nuclear chemistry, industrial chemistry, and all is there. So in that one part we are going to study here. Okay, but if you see in +1, +2 means here we have only 3 parts: only organic, inorganic, and physical. Okay, in that one part we are going to study. So organic is signifies as a life. So what is the organic chemistry means? It is a branch of chemistry which deals with the study of the compounds which are obtaining from the living organisms. I think so nowadays everywhere you can see means here we are seeing some ad. Okay, use organic products, don't use the chemical products and at all. Okay, so because of organic it signifies the life. Okay, organic chemistry plays an important role in daily life also. So, sir, how it is playing as an important role in daily life means, sir, without having food, is any possibilities that to survive in the society, in the earth? Is any possibilities that, ma, without food?
No, sir.
No, ma. Okay, so to grow, maintenance and all, everything, some protein food is required, na? Okay, so living organisms are, they produces some components. That is only we are going to study under the biomolecules chapter. If we see biomolecules, what we are going to study means carbohydrates, proteins, lipids, vitamins. All this part we are going to study now. Okay, all that
Yes,
part
sir.
we are going to study that. That is, so without all that one, it is not possible to growth and maintenance. So organic chemistry is very important. Okay, and so before 18th century, no one knows about the organic chemistry. Okay, at the end of the 19th century, different scientists were they had given different classification for the organic compounds. Okay, so Lamre scientist was that he classified the organic compounds into 3 types. Okay, I'm not writing because of already general introduction is finished. Just orally I'm discussing with you. Okay, if any doubts is there, or if you are getting new points, means I'll write here. Sir, the first scientist who classified the organic compounds means here Lamre scientist. Okay, so Lamre scientist he classified the organic compounds. Okay, so Lamre he classified the organic compounds into 3 types. So based on the sources he classified the organic compounds. Okay, so what are the sources means? One is vegetable kingdom. Vegetable kingdom. Okay, and second one is animal kingdom. Animal kingdom. Okay, and mineral kingdom. And mineral kingdom. So what is meant the mineral kingdom? What is meant the vegetable kingdom means here? And what is meant the animal kingdom means? The compounds which are obtaining from the vegetables is called as a vegetable kingdom. Is any example for organic compounds which are obtaining from the vegetable kingdom? Is any examples? Which organic compounds are obtaining from the vegetables?
Sir, only vegetables or fruits.
Only vegetables and fruits also we can consider.
Sir, lemon.
Okay, so I'm talking about the organic compound. Which compound you know? Which compound you know? You're telling that, let us see, here vitamins are there.
Organic acids which are found in vegetables or in
Yes, yes.
like citric
Vitamins.
acid, tartric acid.
Very good, ma. Very good. Tartaric acid, acetic acid.
Citric acid.
Yes, citric acid. Citric acid is obtained from the lemon, and vitamins also. Okay, carrot. Carrot is having which vitamin? Vitamin A is present in carrot. Okay, so like that, some vitamins are we are getting. At the same time, so from vegetables only we are getting as some protein food. Pea and the tolls, ma. Peas. Okay, so we are getting as a proteins also, na. So vegetables also they contain some vitamins and proteins. Okay, so that we are getting in the form of diet material. Okay, and animal kingdom. So which one we can get from the animal kingdom?
So
So
like
pretty good.
insects like bees and wasps and ants, they have like formic acid and all.
Yes,
They're not exactly useful to us, like they cause harm, but still they produce acids. Like,
yes, yes, yes. Okay, so here also, so some vitamins and proteins also we are getting as from animals also, na. Somebody they lay as a egg. So why you are having as an egg and at all? To have protein only, na. Egg yolk is containing the more number of proteins and carbohydrates also it is there. Is there or not? Okay, so that's right. And mineral kingdom. So what is meant by the minerals? Our body is containing the minerals or not?
Like water.
Minerals. Minerals means the elements which are present in low quantity. Water in body, water content it will be more. Veda. In body, water content it will be more. If you see minerals means in our body is containing iron. Hemoglobin is contained iron. Okay, and sodium, potassium also it is there. Our body is required some minerals now. That minerals are present in the less quantity. Okay, so that we are taking in the form of diet. For example, sodium is required to our body. How you are taking the sodium to our body? You are having diet now. You are having food. Without salt, is any possibility is there to have the food? Without salt, every human body it requires particular amount of the minerals. If we got that deficiency means it causes some diseases. Okay, so mineral kingdom. And the second scientist, who's the second scientist means here? Lavoisier. So Lavoisier is a father of chemistry. You know that one?
yes, sir.
Okay, so Lavoisier is here, father of chemistry. So Lavoisier, he accepted the classification of the Lamare. Lavoisier, he accepted the classification of the Lamare and he has done some small modifications in the classification. Okay, and Lavoisier is telling that the organic compounds are containing carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus also. Okay, so Lavoisier is telling that the organic compounds are containing carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus. In which organic compounds are they contain carbon is a large quantity. So due to that reason only organic compound is how we are defining means the compounds which carbon compounds and its derivatives are we can call as a organic compounds. Okay, but what is the exact definition he has given means Lavoisier. Again, Lavoisier he classified the compounds into two types. One is organic compounds and another one is inorganic compounds. Okay, one is organic compounds, another one is inorganic compounds. So what is meant by the organic compounds means the compounds which are obtaining from the compounds which are obtaining from living organisms. Living organisms is called organic compounds. Is called organic compounds. Okay. Now you got the clarity. So which we can call as organic compounds means the compounds which are obtaining from the living organisms is called as organic compounds. Okay. And another definition also has given. Inorganic compounds. Inorganic compounds. Inorganic compounds. How we can define the inorganic compounds means the compounds which are not obtained. Compounds which are not obtained. Which are not obtained from living organisms. From living organisms. Okay, the compounds which are not obtaining from the living organisms is called inorganic compounds. It's called inorganic compounds. Okay. Right, ma'am. Is any example for the inorganic compounds which we know? Aditi, Veda.
Yeah, sir.
Is any examples for the inorganic compounds as per your idea? Madhusudan, Anjan. Is any example, ma? Is any examples for the inorganic compounds? 12th standard students are there. You have started practicals or not? Anjan?
Sir, is it water, salt, baking soda, such?
Baking soda and all. Very good, ma. Aditi. Good, ma. Okay. So baking soda. What is the molecular formula of the baking soda, ma? Aditi? NaHCO3. Sodium bicarbonate is called as a baking soda. Okay. And NaCl, Na2SO4, barium chloride, PaCl2, calcium chloride. So all these are the examples of inorganic compounds. Organic compounds, yes, ma'am. Examples
What
of,
about plastic, sir?
ma'am.
What about plastic?
So plastic is the organic compound, ma'am. It is a polymer.
Oh, okay, sir.
Okay. So actually here rubber is there. So to be frank, I will tell here. Okay. So rubber is the latex we can call. So we can get us here bark of cinchona. Some are living, some are obtaining from the living organisms, some are artificially we are preparing. Whether you got the clarity?
Yeah, sir, yeah.
Yeah. Okay. So difference it is there. So plastic is the inorganic compound actually that we can prepare by using the organic compound only. Okay. Next. So another scientist, Bergelius, who proposed the vital force theory, ma? All of you. Who proposed the Madhusudan? Who proposed the vital force theory? Vital force theory. Aditi,
Berzelius, sir.
Anjan, very good man. Okay, so who proposed the vital force theory means here? Berzelius. Okay. So Berzelius. So Berzelius, he proposed the vital force theory. Vital force theory. Okay. So what is called the vital force theorem? Vital force. So vital force is nothing but some importance. At the same time, we can call as some hidden energy is there here. Okay. So to produce some organic compounds. If the vital force is not there, means in living organisms, organic compounds cannot be produced. Now you got the clarity. What is in with the vital force means here? Some importance, okay, and we can call as some hidden energy. It is there to produce some of the organic compounds in the living organism. Simple example. So after having the food, our food is going to be digested in the digestive process. Okay, in the digestive process, at the time of digestion, our digestive system it releases some of the juices and it releases some of the enzymes also. Whatever the enzymes it is releases by the digestive system, that enzymes are act as a biocatalyst. Is that clear or not? Is that clear or not? Everyone will having food. How the food is going to be digested means yeah, in the digestive process some enzymes are using one. That enzymes are releases by okay vital force only. So vital force is not there means it is not possible to produce the organic compound. So that is proved by here Bergelius scientists. Okay, and so one more question. Who prepared the first organic compound in laboratory from inorganic compound? Who prepared the first organic compound in laboratory by using inorganic compound? Any one of you. Any one of you. Anjan, who prepared the first organic compound from inorganic compound in laboratory? Sir. Still somebody are there, no one is responding, only 3 members. Sammati, come on. Anjan, yeah. Anjan, what is the answer?
Wöhler, sir, Friedrich Wöhler.
Friedrich Wöhler, very good one. Okay, so Friedrich Wöhler. Friedrich Wöhler, he prepared the first organic compound in the laboratory by using the inorganic compound. Okay. Friedrich Wöhler. Friedrich Wöhler. Sir, next, Sammati. I'm not remembering the names. Okay, next. Samhita.
Yes, sir.
Samhita, what is the inorganic compound he used in the preparation of the organic compound?
Sir, I think urea.
What's one?
Urea, sir, I think.
The first organic compound is urea only. What is the reactant he used in the preparation of the urea? That is my question.
Ammonium cyanide.
Very good, Aditi. Okay, so what is the compound he used means here? Ammonium cyanide. What is the molecular formula of the ammonium cyanide means? NH4CNO. NH4CNO. Ammonium cyanide. Okay, ammonium cyanide. Ammonium cyanide. When the ammonium cyanide is heated at high temperature, it undergoes to the rearrangement reaction and it forms urea. NH2 bond, C double bond O, NH2. So this we can call as a urea. So what is the first organic compound we prepared in the laboratory means urea. How we prepared this from the inorganic compound. What is the inorganic compound he used means ammonium cyanide. Okay, next. Sir, what is the first organic compound? First organic compound Sir, who prepared the first organic compound from its elements, elemental form? From its elements. So here, Kolbe is there. Kolbe is scientist. He prepared the first organic compound. What is the organic compound? Means acetic acid. The molecular formula of the acetic acid is CH3COOH. Okay, so he prepared the first acetic acid from its elements. What are the elements he has taken? Means here from carbon and hydrogen. By using the carbon and hydrogen, he prepared the acetic acid. Some mechanism is that here. Okay, and Berthelot. So Berthelot, he prepared methane. Berthelot, he prepared methane. Okay. Any one of you can tell me the names of methane? We have different names for the methane. I think the 10th standard also we studied about this one. 11th also we got. What are the different names of the methane? Methane also we can call as a coal gas, na?
Sir, is it methyl hydride and marsh gas?
Ma? Come again, Aditi.
Methyl hydride and marsh gas.
Marsh gas. Okay, so this also we can call as a marsh gas.
And sir, it is also known as methyl hydride.
Methyl hydride. So actually it is a hydride form only, na? CH4 it is a hydride of the carbon. This we can call as a hydride of the carbon. Okay, and this also we can call as a fire damp also. This also we can call as a fire damp. So why we are calling as a fire damper? Anyone you are having clarity? Fire damp. So fire damp means it catches the fire from the atmospheric air. Okay, so due to that reason only we can call as a fire damp. We are calling as a marsh gas. So why we are calling as a marsh gas means first it is isolated in marshy places. Okay, so due to that reason only we can call as a marsh gas. And this also we can call as a coal gas also. In coal mines and not all, which gas is going to be released as means methane gas is going to be released as. Okay, so this is about the general introduction of here organic chemistry. Okay, now so we have a large number of the organic compounds. Okay, if you see in all organic compounds means what is the major substance means here? Major element in the all organic compounds means carbon. Is that clear for everyone? So which element is present in more quantity means carbon. Okay, so until today we have a large number of the organic compounds. Okay, so until today we have a large number of the organic compounds. Okay, so why the carbon is forming these many number of the compounds, ma? Why the carbon is forming these many number of the compounds? What is the reason? Sriveda.
Yes, sir.
Why the carbon is forming these many number of compounds until today? Here only we had seen some compounds. Okay, like that we have some millions of the compounds are there. Why the carbon is forming these many number of the compounds? That is my question.
Because it's tetravalent, sir.
Very good, Anja. And second reason, one is correct. So you're telling that it is having the tetravalence. So that is correct only. And one more reason also it is that. What is another reason, Anja?
It's self-linking ability. It can link with itself.
Come on, Aditi. Aditi, little bit louder.
Sir, it's self-linking ability.
Self-linking ability. Very good, ma. So what is, we have some name for that one. Self-linking ability only we can call some name. What is the name of that one?
Catenation.
Very good, Veda. So it's a catenation due to the presence of the tetravalency and high catenation capacity. If you see a whole periodic table, so which element is having the high catenation capacity means carbon. Okay, so which element is having the high catenation capacity in a whole periodic table means here carbon is having the high catenation capacity. Okay, I think so everyone we knows about what is meant by the tetravalency. So all of you know what is mean the tetravalency.
Yeah, its valence
Yeah,
is
sir.
zero. It can neither give or take 4 electrons, so it shares in form of covalent bond.
Very good. Here tetravalency is nothing but carbon. It has the ability to form as a 4 bonds. How many bonds it can form as a how many bonds it can form here? Maximum carbon it can form as a 4 bonds. Sir, how you are telling that carbon it forms as a 4 bonds based on the electronic configuration? Atomic number of the carbon is 6. Electronic configuration, if you check it out, means here. So 2s2, 2p2. This is the ground state electronic configuration. Okay. 2s2, 2p2. So 3 subshells are there. 2 electrons are present in s orbital. One electron is present in p orbital. And whenever in excited state. So whatever the electron it is present in 2s orbital, that it is jumps into the 2p orbital. Okay, that it jumps into the 2p orbital. Whenever it jumps into the 2p orbital means it has a total 4 unpaired electrons. Due to the presence of the 4 unpaired electrons, carbon it has a tendency to form as a 4 bonds only. Okay, so sometimes they're asking the question, what is the covalency of the carbon? Covalency of the carbon. Any one of you. Covalency of the carbon. What is the covalency of the carbon? Covalency of the carbons. Somebody is left. Madhusudan is left. Madhusudan is there. Aditi, Anjan, Samhita left, I think so. Mega. Madhusudan.
Sir, is it its maximum valency, like valency of sharing or accepting electrons?
Yes, but it accepts more than here. It accepts only 4 unpaired electrons only now. In the formation of the covalent, my question is here. So what is the maximum covalency of the carbon? That is my question. Covalency.
Sir, is it 4?
Very good, ma. 4. So why it is 4 only, ma? Why not the more than 4?
Because there is only S and P blocks in the like in the
Very good, ma. Very good, ma.
E block.
Yeah, very good, ma. So because of in second energy level, we have only s orbital and p orbital. So p orbital is having 3 subshells. S orbital is having 1 subshell. So total we have 4 subshells. So due to that reason only carbon it forms as a 4 bonds. It does not form as a more than 4 bonds. Okay. So and one more is also we can write due to the absence of the vacancy d orbital also we can write. Due to the absence of the vacancy d orbital, carbon it forms as a maximum 4 bonds only. You got the clarity, everyone?
Yes, sir.
Okay. And so what is meant by the catenation?
The linkage of the carbon.
Okay, catenation. Catenation. So catenation is nothing but here. So tendency to form as the linkages, longest chains and cyclic rings is called as a catenation. Okay, so carbon it combines itself and it links with other elements also. It links means it forms the bonds with other elements. What are the other elements it is involving means here? One is oxygen, nitrogen, and sulfur and phosphorus also. It forms the bonds. Okay, it forms the bonds with here oxygen, nitrogen, sulfur only printing. Okay, so Carbon, it has a tendency to form the bonds itself, and it can form the bonds with oxygen, nitrogen, and sulfur also. Okay, so now you got the clarity until here.
Yes, sir.
Okay, and one more question mark. Here, while discussing the tetravalency only, so here only we are discussing some hybridization and shape of the molecules and bond parameters we are discussing. All of you, do you have any idea about that one? Hybridization and all. Carbon can exist. How many types of the hybridization?
4 types.
4 types. Ma checkama. Vedda. Whether check it out. How many types of hybridization it exhibits?
5.
No ma.
5.
So you are telling you are telling that max mid forms as a 4 bonds. Max mid forms as a 4 bonds means it exhibits as like sp3 is the highest. Below the sp3, what are the hybridizations are there? sp3, sp2, sp. Okay. But when the carbon it exhibits as sp3 hybridization, how we can tell in that the carbon is exhibit as sp3 hybridization?
Single bond.
Very good. So single bonds are we can consider as a sigma bonds based on number of sigma bonds. Okay, if the carbon is surrounded by the 4 sigma bonds, if the carbon is surrounded by the 4 sigma bonds, means it exhibits as sp3 hybridization. If the carbon is surrounded by 3 sigma bonds and 1 pi bond, then it exhibits as sp2 hybridization. So when the carbon is exhibited as 2 sigma bonds and 2 pi bonds, it exhibits as a sp hybridization. Any examples? Fatavat? Examples for the sp3 hybridization from your hydrocarbons one.
Sir, alkane.
Alkanes, very good. So best we can take as a methane or ethane. C2H6. Next,
Alkenes.
alkenes. What is the best example we can take? Ethene, CH2 double bond CH2. And what is the last one?
Alkyne.
Alkyne.
Very good, alkyne. HC triple bond CH. So similarly, can you tell me the shapes of the molecules? If it is having sp3 hybridization, means what is the shape of the molecule? Veda.
Yes, sir.
Tetrahedral. No ma, it's a tetrahedral.
Yes.
Okay. And sp2 hybridization.
Linear.
Anjan, come again.
Linear.
sp2 hybridization is trigonal planar, Anjan. Trigonal planar. If it is sp hybridization means linear. And bond angles, any one of you? Bond angle? Just I'll finish this one. 1 minute only. What is the bond angle for the tetrahedrals? If it is having tetrahedral shape means. Sir, 109 degrees, 28 minutes, Anjan. Next, what is the bond angle in trigonal planar shape?
120.
Very good, Aditi. 120 degrees. Okay. And what is the bond angle in sp3, sp hybridization?
180.
180. Very good, Arjun. Okay. So same concept again we studied in the chemical bonding chapter also, and here also you will get. So because of whenever you're going to study haloalkanes, haloarenes, means there also we are discussing about the bond parameters. I think so everyone knows about the bond parameters. Bond length, bond angle, bond energy. Okay. So bond order. All this part we are also discussing. Okay. So hopes everyone you enjoy the class. All of you? Okay, all of you understand now?
Yes, sir.
Okay.
Yes, sir.
So okay. So next directly I'll start with the nomenclature. Are you sure? Can I start with the nomenclature? All
Yes.
of you? Okay, right. So then we'll go over the IUPAC on that nomenclature part I'll discuss in the next class. Okay? So thank you all. Have a good day, man.
Thank you, sir.
Thank you.